This is an operational amplifier PCB board. The inverting terminal is shown in the triangle with the minus sign, and the non-inverting terminal with the plus sign. Components and wires can be added to the circuit using the various grey screw terminals around the board. This is the signal generator. It generates waves that can be viewed on the oscilloscope. The big dial on the left can be used to change the frequency of the wave. The square buttons on the right can be used to select a type of wave. We can now use a wire to connect the output of the signal generator to the channel 2 input of the oscilloscope for a pictorial representation of our signal. In order for our op-amp to work, it must be supplied with power. We are using a 15 DC supply. There are 3 wires. The top shows a V+ on the supply box, the middle one is a grounding wire shown as 0 volts on the box, and the third is a negative voltage, V- on the box. We must plug them from the supply to the corresponding plus, ground and minus shown on the bottom right of the PCB board. I have plugged in the black grounding wire and will demonstrate how the screw terminal works by plugging in the negative volts bottom wire. You simply slot the wire or component into a terminal and then with your screwdriver screw down until it is completely secure. If the DC supply has been connected correctly, the LED lights on the PCB board will turn green as shown. Now it's time to add your resistors to the circuit. Take R2, the 100 kilo ohm resistor, and screw it into the terminal labelled R2 on the board. Now put R1, the 1 kilo ohm resistor, into the R1 screw terminal. By using the splitter on the signal generator, we can feed the same signal that has gone into channel 2 of the oscilloscope into the PCB board. We screw it in at the in terminal, as shown. To ground our signal, we take the black wire and plug it into the 0 volts terminal, as shown. To ground our output signal, we take a black wire from our output of the PCB board and plug it into the black part of channel 1 on the oscilloscope. To get the signal on our oscilloscope, we plug the red wire from the oscilloscope into the output of the PCB board. To close the gaps in our circuit, we must add wires between the C1 terminal and the R5 terminal. The wires look like this once they are connected. Finally, we must add the capacitor to our circuit into C2 to change our inverting op-amp circuit into an integrator circuit. To show the integration of the wave clearly, I have selected a square wave signal to pass through the integration circuit. As you can see, the resulting wave is triangular as expected. I have passed a sine wave through the circuit when the larger 0.1 microfarad capacitor is inserted. Note the volts per division at the bottom of the left screen. From this you can work out that the amplitude of the sine wave is around 50 millivolts. Inserting the smaller capacitor now. Note the volts per division have shot up to 500 millivolts. Now the amplitude is around 500 millivolts. There is a factor of 10 difference in the gain between the two capacitors as expected. So clearly the capacitance changes the output signal of this circuit.